Why did this dominant Morrison Formation giant consistently become the primary hunting target for ruthless apex predators? How did specialized ligaments running from the hips to the neck base allow completely effortless horizontal grazing? What ancient survival strategy drove these massive herbivores to consistently travel in surprisingly small protective family groups? Could an 80-vertebrae tail actually function as a devastating biological weapon capable of shattering massive predator skulls? Why did narrow, slender front teeth evolve into a highly specialized comb mechanism for efficiently stripping foliage? What unique skeletal formation beneath the heavy tail vertebrae originally inspired the famous double-beam scientific name? How could these colossal reptiles achieve full adult mass within just 10 to 15 incredibly short years? Don't miss what comes next in this story. Watch to the very end.
Hello, I am Jonny Dony, and welcome to a channel dedicated to dinosaurs grounded in real paleontological science. In Shadows Cast by a Living Frame, we trace the massive Diplodocus across ancient floodplains, facing seasonal droughts. Monetization here has grown unpredictable lately, so this channel relies entirely on direct viewer backing to keep going. Becoming a sponsor on Patreon ensures every single contribution helps produce the next documentary film, link below. Please like and subscribe to support the channel. Now, let me take you back in time.
Shadows cast by a living frame. The fossil record is a broken mirror reflecting a vanished world. End. Stephen Jay Gould. Jurassic Floodplain. The Morrison Formation sprawls across western North America in bands of red rock. 154 million years ago, this arid floodplain supported vast herds. Diplodocus is the defining icon of this ecosystem, outnumbering other sauropods across the ancient basin. Seasonal rains carve shallow river networks through the sprawling conifer woodlands. A lone theropod silhouette passes quietly at the distant horizon while giant browsers move through the green interior. The complex ecological network thrives on these brief, violent, wet periods. Open fern prairies fill the dappled gaps between the towering ancient trees. A small synapsid scurries peacefully beneath a fallen log near the watercourses. No flower has yet opened anywhere in this world, for the angiosperms lie far in the future. The Kimmeridgian stage brings extreme climate fluctuations to these vast ancient plains. Extended dry seasons parch the landscape, concentrating populations near remaining water sources. Braided streams constantly shift their channels, depositing rich sediment layers that nourish rapid plant regrowth. This dynamic habitat shapes the food web of the Late Jurassic. Diplodocus serves as a primary prey target for apex theropods like Allosaurus within this environment. The sheer numbers of these giants sustain the complex ecological network across the continent. The Morrison Formation stacks 9 million years of deep geological time in its reach. Through all of it, the gallery forest falls and rises green with the returning rains. Bed by bed, the geology writes its long record into stone. This chapter reveals that Diplodocus dominated the Morrison floodplains through sheer population numbers. We invite your observations on this ancient ecosystem below. Like and subscribe to help us preserve these deep-time investigations. The next chapter examines how horizontal neck ligaments enabled efficient grazing across vast plains.
Quadrupedal species. This quadrupedal species prioritizes reach over brute mass. It stretches 24 meters long while weighing roughly 15 metric tons, Its lightly built body plan moves steadily through the Kimmeridgian floodplains, elevating the heavy torso well above the dense green fern undergrowth. Ligaments extending from the hip to the neck base allow the animal to hold its neck horizontally without muscle strain. This enables efficient feeding across wide grazing areas. Meanwhile, a tiny Fruitifossa scurries peacefully beneath the sweeping and elongated shadow. Noticeably shorter forelimbs contrast with robust hind limbs. This creates a sloping back that perfectly balances the 80-vertebra tail. The distinctive anatomical arrangement minimizes structural weight across the spinal column, enabling sustained, highly energy-saving movement across the vast open floodplain terrain. Narrow bony projections occasionally line the dorsal region. These preserve essential flexibility for rapid directional adjustments. A plated Stegosaurus browses quietly near the distant conifer tree line, providing a stark, heavy contrast to the giant's remarkably slender and highly elongated body silhouette. The species reaches immense proportions, yet its lightweight frame allows it to navigate the semi-arid floodplains with surprising agility. It sweeps its head side to side, stripping low-growing vegetation without ever needing to shift its substantial, heavy body mass. The long neck projects forward rather than upward. This maximizes the grazing area from a single standing position. As the animal shifts its weight on 4 pillar-like legs, the exceptionally long tail extends straight behind, acting as a perfect counterbalance in motion. How did such a massive creature move efficiently across dry floodplains? We examined specialized ligaments and a counterbalancing tail that minimized energy expenditure during long migrations. Subscribe and like to support our documentary research. The next chapter reveals how these giants gathered to protect vulnerable hatchlings from harsh seasonal conditions.
Brood nesting. The breeding season draws scattered individuals into a massive social gathering. Adults arrive at the sandy basin to prepare a shallow nest. Evidence suggests Diplodocus traveled in small herds for protection, making it one of the most abundant sauropods across the Kimmeridgian-Morrison Basin. Each parent carefully deposits a clutch of leathery eggs into the warm sand. The buried clutch incubates under the bright, seasonal sun. Nearby, a small Dryolestes scurries through the dust, navigating the vast nesting ground while the giant adults remain vigilant. Tiny hatchlings break free from their fragile shells after weeks of steady development. These small juveniles must grow rapidly to survive the harsh conditions. High mortality rates claim many of the young before they can fully integrate into the protective social group. Deep vocal calls resonate across the open basin to maintain constant contact. A low rumble signals the herd to move together, keeping the vulnerable young safely centered. Overhead, a Dermodactylus drifts on thermal currents, observing the coordinated migration of the massive gathering. Social cohesion emerges from these shared survival pressures rather than permanent familial bonds. Every watchful parent monitors the outer periphery, ensuring no isolated individual falls behind. The collective vigilance provides a crucial buffer, allowing the young to navigate the dangerous landscape securely. As the dry season shifts, the entire herd begins a coordinated migration across the basin. Adults and juveniles travel in tight formation, their low calls echoing in the dust. This unified movement ensures the next generation survives to breed in future seasons. While earlier chapters detailed isolated anatomy and terrain, this sequence reveals complex social nesting behaviors. We documented how collective vigilance protects vulnerable hatchlings during harsh migrations. Subscribe and like to support our ongoing paleontological research. The next chapter shifts focus to coordinated predator defenses.
Predator combat. Two massive Diplodocus rivals clash in the dry fern savanna. Their necks intertwine in a brutal test of raw mass. The larger bull shoulders his competitor sideways, driving 15 tons of muscle until the rival yields ground and retreats. A sudden threat emerges when a Comodactylus dives toward the group. It seeks an isolated youngster near the edge. An adult pivots sharply to break the attack rhythm, forcing the startled flyer to veer upward into the open sky. An Allosaurus launches a slashing attack on the flank. The sauropod unleashes its primary defense in response. Its tail contains about 80 vertebrae, nearly a third of its body, forming a whip that delivers devastating defensive blows against the predator. Later, a younger bull attempts to compete for position. He moves near the river's edge to challenge the group. The dominant matriarch steps into his path, delivering a firm warning strike that knocks the young challenger completely off his balance. An Amphicotylus stages a sudden ambush from the shallows. It snaps at a small trailing youngster near the bank. The massive adult pivots, bringing its muscular tail down in a crushing arc that repels the crocodilian back into the murky river depths. Whew. As dusk falls, a Ceratosaurus makes one more desperate strike at the perimeter. The group forms a tight defensive ring to protect the calves. A sweeping tail blow lands squarely on the snout, driving the heavy theropod safely away into the dark. Our investigation shifts from violent encounters to a precise feeding strategy. Surviving those attacks demands constant energy, which we explore next. Like and subscribe to follow our ongoing documentary series. Chapter 5 reveals how specialized comb teeth and ground-level grazing sustained these giants.
Diet strategy. The massive herbivore lowers its heavy head to the damp soil. Narrow, pencil-like structures at the front of its mouth act as a precise comb, stripping soft leaves from low-growing plants. This specialized diet strategy avoids high browsing entirely, maximizing energy intake. Swallowing the intact plant material reduces processing time. The animal steps forward, pulling its neck backward to rake fresh, dense vegetation into its mouth. Nearby, a massive Stegosaurus slowly crops cycads, leaving the ground-level forage completely untouched for our giant. Thirst eventually drives the feeding group toward the braided river channels. As the giant drinks, a small fruitifossor scurries through the horsetails along the muddy bank. This continuous routine demands constant movement across the vast territory to locate fresh resources. By midday, the sun bakes the open fern savanna. The giant shifts its weight, moving to a shaded patch beneath the conifers. High above, a long-necked Brachiosaurus strips the upper canopy, perfectly partitioning the environment and leaving the lower strata completely open. This ground-level grazing methodology minimizes competitive overlap with much taller browsers. By targeting only the soft, nutrient-rich shoots, the animal secures reliable energy reserves without expending unnecessary calories. The sheer volume of daily plant consumption easily sustains its massive bulk. As dusk approaches, the giant moves on to the next heavily depleted patch. Its constant cropping shapes the local vegetation structure, encouraging fresh regrowth across the plains. This relentless appetite ultimately maintains the delicate biological balance of the entire ancient landscape. This chapter reveals that pencil-like comb teeth allowed massive herbivores to monopolize ground-level vegetation. We want your analysis of how this feeding strategy influenced herd survival. Hit like and subscribe to fund our continued documentary production. The next chapter documents a severe drought that collapses this fragile ecosystem.
Apex extinction. The dominant giant strips low ferns across the Kimmeridgian basin. Hydrology shifts as seasonal rains fail, shrinking the rivers that sustain this vast assembly. An apex herbivore of immense length, it commands the drying landscape, outcompeting smaller contemporaries like Dinosaur for the remaining foliage. Its name means double beam, referring to the chevron bones under its tail vertebrae. Thought unique when first described by Marsh in 1878. These structures stabilize the massive appendage, allowing final dominant individuals to sweep encroaching theropods like Allosaurus from the parched margins. As the Kimmeridgian stage concludes, shrinking lakes concentrate the remaining assembly. Massive Apatosaurus competitors wander the cracked mud, unable to find sufficient vegetation. This terminal drought strips the landscape bare, forcing the great giants into a desperate, final struggle for the last viable grounds. The regional die-off accelerates as widespread floral collapse starves the dominant populations. Starving individuals collapse beside dry riverbeds, their immense frames unable to sustain basic metabolic functions. Even the largest theropods, like Torvosaurus, gather at the margins, driven by the same catastrophic lack of resources. Dust storms bury the empty plains where these giants once roamed. The final survivors stagger through the barren expanse, their heavy footfalls echoing across the silent Kimmeridgian basin. With no foliage left to sustain them, the great assembly faces its ultimate, unavoidable conclusion. Ultimately, the terminal climate shift eradicates the dominant herbivores from the ancient continent. As the Kimmeridgian fades into deep time, the empty basins await new evolutionary experiments. The prolonged drought claims these gentle giants, leaving only silent shadows cast across the shifting sands. While earlier chapters tracked thriving herds, this sequence reveals their sudden ecological collapse. We document how prolonged drought ultimately erased these giants from the basin. Subscribe and like to support our ongoing research. The next chapter details how sediment preserved their complete anatomy.
Fossil legacy. A mature Diplodocus strips ferns across the Kimmeridgian Morrison floodplain, its 15-ton frame casting a long shadow over the cycads. This giant herbivore moves steadily through the semi-arid basin, consuming vast quantities of low vegetation to sustain its immense daily bulk. Growth rings in their limb bones reveal these giants reached full adult size in just 10 to 15 years. High juvenile mortality is inferred from abundant small bones at ancient predator trap sites. There, a fallen carcass soon becomes carrion for gathering scavengers. Sediment slowly burying the remains preserves the articulated skeleton within fine-grained mudstone deposits of the Morrison Formation. Over millions of years, mineralized bone replaces organic tissue, locking the 24-meter frame securely into the geological record. until the rock eventually fractures. Modern excavation campaigns recover these fragmented specimens from massive bone beds across the western United States. Paleontologists carefully extract the preserved vertebrae, reconstructing detailed anatomical profiles that clarify how this lineage fed and defended itself against contemporary local theropods. Analysis of the recovered skeleton highlights a tail containing 80 vertebrae, specifically designed for kinetic defense against predators. These fossilized elements provide concrete proof of the biomechanical adaptations that allowed this specific lineage to dominate the late Jurassic ecosystem. The accumulated fossil record permanently documents the evolutionary success and eventual disappearance of this remarkable herbivore. Scattered teeth and massive limb bones, now resting quietly in museum halls, stand as the enduring legacy of a giant written in solid stone. Our exploration of the Morrison floodplain concludes with these fossilized remains. We invite you to examine how rapid growth shaped this ancient ecosystem. Please like and subscribe to support our documentary research. Explore our full channel archive for additional prehistoric investigations.
Our journey through shadows cast by a living frame reaches its final chapter, and I'm Jonny Dony. The Diplodocus revealed how elongated frames and reinforced tails shaped survival across ancient floodplains. Please subscribe and share your favorite discovery in the comments today. Every new documentary lands on Patreon a full week before the public release, link below. Sincere thanks to my subscribers and sponsors whose steady support funds careful research and animation. I deeply value the time you spent exploring prehistory with me. In just a few seconds, 2 upcoming dinosaur documentaries will appear on your screen. Choose your next story and keep discovering ancient worlds with me.